Okay. So, wanted to do some training over the next couple of weeks over different topics that we want to try to get in better processes and better development structure on how we do some of our coding. And so one of the first things I want to talk to you today a little bit about is doing test-driven development and how that will actually help us write some better code. So we're going to go over a few slides, and then I'm going to go over a few different examples on how test-driven development can help you write better code in the long run. Okay, so what is TDD? TDD is a development process that relies on very short development cycles with a sequence. The first sequence is to write your test first. And so what we have here is basically the steps that when you write TDDs, normally how you go about doing this. And so the first thing you would do is you'll write a test, run all of the tests that you have, and then see if that test passes or fails. Because there is some situations where you may have a requirement come through and you write that test and the code already does what you expect it to do. And so you can write that test, the test pass, and then you can move on to the next thing that you need to work on. Most likely, though, that your test will actually fail. And so what you would do then is you would start writing code to get the test to eventually pass. And so you keep running all the tests until that test passes. Once the test passes, then what you'll do is you go back to your code and you refactor it, making sure you have it completely cleaned up to the best of your abilities and making sure everything's done the way it should be done. So here's some of the benefits. We'll go over a little bit of this. So one of the things that doing tests first will help is it will provide constant feedbacks on whether your component is still working. What that means is that if you have say a service and you have 10 or 15 different things going on in your service, making a change to a common method may affect other pieces of your code. And so running your test continuously and writing the test first will give you feedback on whether or not the rest of the methods are working as designed or whether things go out of date. Another thing that tests do is it gives you a constant documentation on what your classes are doing and what the classes are. You know, normally when we do design docs or you're doing documentation of your application, those can go out of date very quickly because you usually do documentation, then you write all your code, then hopefully you go back and update your documentation. Sometimes you don't, sometimes you do, and then you're on to the next version. And then when you get to the next version, you start writing new documentations that may or may not conflict with the documentation that you did before, and eventually then your documentation gets really out of whack and no one really knows what documentation is valid, which is not. Unit tests actually can document your code, and if the unit tests are passing, that is what that code is supposed to be doing at that moment. And so doing a baseline and a delta of your code using unit tests is actually a very good way to go for documenting your code, because you do have a baseline. You write your test to give you your delta of what you want to change, and then eventually the test will pass and that will become your new baseline. Skip down to a little bit further down. That software tends to be better designed when you write your test first. The reason why this is, and we'll go over this in one of the examples, is normally to be able to write your test first, you kind of have to know what your code is doing, and you actually should design your code first. rather than just kind of go through your code and start coding and then come up with design after you started coding. And so if you're doing true TTD, you would actually do your design docs first and write your design docs in a very detailed manner. That way, when you move forward, all you're doing is basically going over your design doc and taking that pseudocode and actually writing real code with it. The next one is kind of goes back to the first one, where the test suites actually act as regression on bugs. And so as you're getting your test suites larger and larger and covering more and more of your code, making a change to a common piece of code, so say a factory of some type or a constant, if that change then affects code that is not necessarily your code but someone else's code, if you run your test, then that will find whether or not that code will break based on your changes, and it's not necessarily just your code. And the last thing it does is it does do a pretty good job of trying to cut down on your debugging time. Because if you write your test first and you know then that your test has passed, when you actually get into your code and you're looking at it visually on a web page or on a visual widget, you normally don't have to go through as much debugging because you know that that piece of the code that you wrote is working as designed. Some of the keys for doing test-driven development is keep your unit tests small. So test the piece of the code that you need to test. Don't try to test everything at one time. That makes it, goes into the second piece of doing a KISS principle. Keep it super simple, stupid. Make things simple. Don't try to get real complicated with your test, because the more complicated you get with your test, the harder it is to start testing things, and you can get into a frustration period there where you don't necessarily know how to test your code because it gets really, really complicated. Make it smaller, test little individual pieces, and then build on top of that to get your unit test to be able to cover all of your code. Run your simulation, simulate the environmental dependencies. So this goes back kind of to keeping the unit test small. You want to keep things as small as possible. Study, can you put on? There we go. If you isolate your processes and keeping it small, it's a lot easier to test your code at that point, and you know that that particular piece is working and should not necessarily be affecting other pieces of the code. When you don't isolate your code, what happens to you a lot of times is things seem to be working, but you don't understand why they necessarily are working, or something may be failing and you can't find it because there's so many pieces to the puzzle that you can't isolate the little individual piece that you need to isolate. Whenever possible, use as real of data in your mocks as possible, but don't necessarily use real data for the sacrifice of speed. Example would be if you have a list that in the real world will be 5,000 units long, use 20 to do your test. You don't necessarily use the full 5,000 unless there's some real specific reason why you have to test that 5,000. Because normally with a lot of tests, you can know whether your test is running properly or not with just a small subset, and your test will run a lot faster than trying to run with 5,000 units just so you can replicate the production data. Run all of your tests to verify your changes. This is very important because especially if you're using methods inside of your classes that are common, or you're using utility classes to help on doing things, if you make a change to those, you may be affecting more than just your code. You may be affecting other pieces of the application that you don't necessarily know are being affected. So make sure you run all of your tests when you get finished. And the last one is clearly reveals its intention. So the test should actually tell you what you're doing and what you're trying to do. Even when you walk through the steps of the test, you want to be able to look at and be able to say, okay, this is what I'm doing. What this actually does in reality is when you bring new people on board, this is a good way for them to be able to look at your code and figure out what's going on. It goes back to documentation. And so if you clearly reveal the intention of your test, you should be able to give this to a new user or new developer, and they should be able to look at your test and go, okay, I understand now what this class is trying to do and what these methods are doing, because it's clearly defined within your test what's going on. Oops. The downsides to TDD, integration testing. So doing test-driven development doesn't necessarily finds all the bugs and integrates all your tests and integrates all of your application. And so a lot of times when you're doing test-driven development, you don't necessarily test from end to end, and not all of your tests will cover end-to-end testing. And so sometimes it can be very difficult to find certain bugs in the system because of that. And to be honest with you, doing test-driven development doesn't necessarily find all of your bugs because we're all human. We know what we want our test to do, and so we'll test that and try to do those. If you're really, really good at it, you'll do negative testing. You'll know some of the gotchas, and you'll test that. But, you know, there's never been a application written that hasn't been bug-free except for some of the stuff Kevin's written. But other than that, nothing has been bug-free. And so don't think that just because you're doing tests first that you'll find all the bugs. Since you do design in the beginning with test-driven, design can change quite a bit over the period of time that you're doing development, because you'll start writing your test and then you realize that that design doesn't quite fit what you need, or new bugs or new requirements come in. And so rather than just jumping in the code and trying to shoehorn stuff in, you actually will design first and then write your test. And so your designs will change quite a bit. And that can be difficult for some people. It is a downside to it, because a lot of times you won't have a set design in the very beginning. It will change constantly. And that's one of the reasons why test-driven development is very much akin to agile processes, because things change from sprint to sprint very easily with this. Some of the code can be difficult to isolate and test. I know in some of the applications we have today with like binders and even batch, because of some of the complexities that we're trying to build in to simulate other type of applications, sometimes it can be very hard to isolate and test certain pieces of code before you even write it, because you're not 100% sure how you're going to even do it, so it's hard to write that test. Okay, and then the last one is it can be very hard to get started with, because especially with greenfield type of applications, because you don't know how you're going to implement it yet. I mean, you're still trying to figure out what goes where. The design may be there, but maybe very loosely designed, and so it can be very hard to write your test to start off with without knowing what you're going to do. And so that is definitely one of the downsides. And then the last slide that I have here before we go into some examples is some of the processes based on TTD. One is behavior-driven development, acceptance testing development, and story development development. What these processes are nothing more than how you write your test, not necessarily when or why you write tests. It's just how you write your test. And so acceptance test-driven development is probably one of the more applicable ones that I've seen, mainly because when you write stories and your test team takes those stories and starts writing acceptance test for them, what you do is you take those acceptance tests and then you will write in the very beginning your unit test based on those acceptance criteria. And that way, when you get done with writing your test and all of your tests pass, you should know with a high degree of certainty that the testers won't find any issues with your code because what they're looking at is the same thing that you wrote tests for. Behavior-driven is more along the lines of when you're looking at integration testing and you actually look at a web browser, how people click through your application to do certain things. And so you write unit tests based on that. And so you'll say a user will come onto my home page and they will click on this button and then they will get this page and then they will click on this button and then they will get this page with this stuff on the left and this stuff on the right, and I want to make sure that is tested. And you write your test based on that behavior. Then story-driven is strictly right out of agile development processes where you take that story, you write tests to satisfy that story, and then you're done. Okay. To me, the acceptance test-driven development is one of the better ways because you're basically taking what you know is going to get tested and write tests to make sure that they passed. Okay, so that. Any questions on the slides? Give it a second in case anyone's on mute. All right, bonus. Okay, so what I'm going to do is we're going to go over a few examples of TTD. I'm going to kind of start backwards and then work forwards on this because I think the first example is more of a real-world example on how to do this, and then we'll kind of move forward from there. So I have this app here. It's a very simple app. It basically has on the left-hand side the list of NFL teams. If I click on a team, it will give me the team info. I can switch over to the European Soccer League and the same thing. Okay. Not a whole lot to this application. There is a front end and a back end. And here I have my 27 unit tests for my application. If I bring up a coverage report, I think I'm around 90-something% coverage on this. There's a few if statements that I haven't received. But you can see here, like here's my data services. And if you can't see this, tell me and I'll bump up the fonts on this. But in my data service, I want to get NFL teams. There should be 32 of them. I should call and get the European League. There should be 20 of them. Tested only success calls is not error. Just all the different things that happens within my data service on calling things. Okay. Come over here. So, I go into TFS or whatever bug application system I have, and I get a bug that comes up and it says, the order of the NFL teams, the Giants should become before the Jets. And so when I look at my code here, I can actually see that the Giants are coming after the jets, and that is incorrect. Okay. And so I know after looking at my code and kind of doing a little bit of research that the problem is that the data that I'm getting back from the server is not ordered. Okay. So what I'm going to do is I'm going to write a test. And my test says, should test that giants come before the jets. Okay. And I have a faking the back end. This NFL teams here is a mock data of the actual data that I'm getting back from the back end. And then what I'm saying here is that on data point 18, it should be the giants, where the expected data on 19 should be the jets. So the giants should come before the jets. If I save this, you can see here on my test over here now, I have a failure because obviously the data that I'm getting back right now is not correct, and I got to figure out now, I got to write the code to solve that issue. Okay. So if I come into here, I know I can come here and I can do data dot sort function. Okay, so now what I'm going to do here is, if I didn't write my test beforehand and I'm just coding at will, what I would normally do is I would do something like this. Okay, and then I would say, yeah, I'm just going to check this in and everything's going to be fine and dandy. And I hit return, but because I have written the test before, you can see the test did not pass. Okay, and so rather than just write this code and then check it in because this is how sorts work, I'm actually running the test continuously to make sure that this is doing what it's supposed to be doing, and it's not. And that's one of the advantages of test-driven development, is because you don't necessarily will check in a code and look at things past your little bit of code until you know it actually passes. I could run this and then go into my app and then try to figure out, well, why is it not working now, and go back and forth. But with this test-driven, I know I've isolated that this piece of the code is not working. And so, because I know my code well enough, I know I should be able to do this, and now my test pass. Okay. And in reality, now it should, if I come into here, you can see now the giants come before the jets. Okay. The second thing that this has done is, because this is a bug, I have written this bug into my test to test this corner case. Now, these are very contrived examples I'm giving you, are very simple. The likelihood of this being a true corner case is very slim. But I have been in situations in the past where we had very unique corner cases that, you know, happen actually quite a bit in the real world, but when you go through testing and QA testing, it really didn't happen a lot because it was a very, very unique situation. The developers did not write unit tests to test that corner case, and so they fixed it. We put it in production, everything worked fine until the next release, when someone made another change. Because they didn't know about the corner case, they actually reversed out the original change, and the corner case broke the next time we pushed out. Okay, and like I said, because it's a corner case and no one had it written down and no one put it in unit tests, and the QA team thought it was fixed, so they didn't test it again, it actually got pushed back out in production a second time. If you write your unit tests and you put your bugs and corner cases in your unit tests, then if someone comes back and changes the code and it breaks, then that should send up files to say, hey, something's not quite right. We got to figure out why it's not working. Okay, and you can find, you can alleviate some of your regression issues that you may have by doing that. Any questions on that simple little test? Okay. So let's go into the next example. So the next example is I have here on the second line, a requirement comes in that says I want to be able to toggle the switch to sort the NFL teams by nickname or by location. Okay. So I know that is going to be in my main test here. So the first thing I want to do is let's see here. And I can't remember which one I did here. There's a design doc. Design one. There we go. So whether you write you have a solution document, a design document, whether it's on pen and paper, however you want to do it, normally what you should do is you should have some type of plan and design before walking into start development in your code. Ideally, you would have a design document and you have a baseline and you write a delta to it, and then once you get done with that delta, you put that back as the baseline and everything's fine and dandy. That's in a perfect world. I don't think any of us have ever been there. But another good way of doing it is just put on pen and paper what you want to do beforehand. And so that's what I've done here. What I've done is to satisfy these requirements, these are three things I wanted to do. I wanted to create a scope item called scope.sortName. I want to create a scope function called toggleName to toggle the sort name from name to location. And then the last thing I want to do is create a ngRepeat test to test the visuals. Okay. So the first test here is I should expect a default sort to name. And so what I'm doing here is I should expect that there should be a scope item called sort name, and it should be named to start off with. The next test here I have is I want to test toggle function will change sort name from name to location. Okay, and so what this does is it says I expect the sort name to be named to start off with. I call my function toggle name, and then I expect it to be the sort name to now be location. And then the last piece is this, where what I'm doing here is I'm creating an ngRepeat in Angular. I'm compiling it, and then I'm looking to see what the order is of the NFL teams that I'm passing into it. And then I'm calling the toggle, and then I'm looking back in it and making sure that the names have actually changed and the order has changed. Okay? So I hit save, and you can see here, now all three tests have failed. So now I come in here, and based on my requirements, the first thing I want to do is I want to do scope, sort name, okay, then the next thing I want to do here is I want to do the scope toggle name equals the function
उसके बाद शास्त्री हम प्राइवेट कर लेते हैं, शुरू हो जाता है, इसके साथ ही लौकी तक और इसका लाभ इतना है कि जो जेल से पड़ता है।
Sadiq, can you mute yourself?
Sadiq, can you mute yourself? There we go, thanks. Okay, so what I did there was I've created my sort name, I created my toggle, and you can see now that all three of my tests have passed, okay? And so I'm now very confident in my code here that if I go in and change my HTML, let's see, main here, that's not it. And let's see here, I want to add this button here, and I'm going to change this. Open this HTML back up. Now I have a button, I have names, so these are all sorted by name. Something didn't quite go right. Oh, that's right, because location and name are the same. Let's change this to nickname. Yeah, that fails now. I forgot. I had to make some changes yesterday for this. But you know, the test passed, and now you're working on knowing that that code is actually working within your controller. Now you can look at the page and figure out why the page may or may not be working. I think I actually have a typo in that page, if I remember right, that I have to fix before this afternoon. So that's an example of how you would take a requirement, write your test first, and then move forward. Okay, any questions on that real quick? Okay, let's talk a little bit more about, though, a real-world example on how things normally would go. So what I'm going to do now is I'm going to create a new filter. Okay, so I created a new filter here, and most likely the way you're probably going to end up doing development is going to be more like this. Oops. Is I have a requirement for this filter that I want to remove all of the P's from an application. And, okay, that was weird. And so, you know, a lot of times, you know, I don't necessarily know how I'm going to do this, okay? And so, what you'll find out a lot of times, the way this will work is, I'll write some of the code to start off with, and then start writing unit tests. And so this is going to be an example of that. And so, because I used Yeoman and I created my filter, it automatically created my test for me. It probably went by a little bit fast, but there was a unit test created for it automatically, and so here's the unit test. And I don't know how I'm going to do this, and so I'm just kind of going to start working on it. And luckily, I kind of know how I want to do this, and so what I'm going to do is input.replace and so that should do what I want to do. Now, the test failed here because when we create these unit tests using Yeoman, we're just doing a default. And one of the reasons why we did the defaults for the unit test was when you made changes to that code and you saved it, it should fail the test unless you went back and changed the test. So now what I can do is I can actually now start writing tests to test to see if this did exactly what I wanted it to do. So if I come into my test here, I want to do, okay, I want to see that the lowercase p will change to be an empty string. Okay, and that did not pass. So I know that my code isn't working quite right. And so what I would do now is I would continue to work on this method, trying to figure out why that test didn't pass, and get the test to eventually pass with all the unit tests that I need to do to get this done. So another one would be if I take this and I want to take a capital P, and it should be the same thing. Now there's two tests that will fail. And I just continue to do this, and I'll test my individual code in all the different scenarios to get that to work, rather than writing this filter and then putting the filter into a repeater or into a string and test it there. I can test it here until I get to a point that can work, and then I can move on and put it into other things and make it work in other places. Okay, and I think that's where you will probably find most of your unit tests, most of your test-driven development working, is that you will actually write some code and then write a test to try to make it pass, and then write a little bit more code and then write the test to make it pass. What I would do is use your tests to do your development work rather than just writing tests just to see if it, so you can get the coverage and making it pass and making people happy just because you got unit tests and coverage. Actually use the unit test as a tool to work on the code that the development. I know with me, especially in the Java world, rather than ever hitting backends and pushing code out anywhere, I would actually use the unit test and run my code through unit tests and get work with the unit tests before I would even put it into the main body of the application, and then run tests there to make sure it passed. And then the last step would be running the application and making sure all your code works at that point. And I think what you'll find is doing it that way, you'll actually write better code, you'll have less bugs, you'll have less feedback onto your code on issues that you had because you actually tested all the individual pieces and you know all the individual pieces are working. Now, one of the downsides to test development is with web-based applications and looking at web pages, it's very hard because a lot of the bugs we'll get is something is not in the right spot, or it's 5 pixels too far left, or 5 pixels too far right. You can write unit tests, or you can write tests for that with like Protractor and using Selenium, and you can actually get visuals of that. Another way of doing it is taking Phantom and taking screenshots of the pages and then comparing it to other versions of the application and see if things changed. And so you can actually write tests beforehand to do that. It's just a lot more difficult, especially nowadays with as many browsers and as many resolutions that you're trying to go with. For an individual developer to do that is very difficult, and probably isn't using the best of your time trying to do that. But at the lower level pieces of code, like in your controllers, definitely in your services and your filters, writing the test beforehand and using the test to make sure your code is solid before you even test it outside of it is definitely a better way of going, and you know more about your code at that point. Okay, so we have about 10 minutes if anyone has any questions, any thoughts. The training at 3 is the same thing. I'm going to go over this again. I just want to have 2 different times for people in case you couldn't make it in the morning, you can make it in the afternoons, especially since we have offshore and onshore. So, there's no need to come to the afternoon one if you've been to this one. Okay. Well, if there's no questions, I'm going to stop the recording, and then on Tuesday I'm doing training on directives, and so we'll go over directives from head to toe, what all the different fields do, what you can, all the different parameters within a filter, and we'll also talk a little bit about the processes that run the directives and stuff. So that should be a good training session there. If you guys have anything else you want me to go over, please send me an email. This goes over anything. So if it's just regular JavaScript, going over anything in Angular, going over anything in Protractor, Jasmine, Karma, Grunt, anything you guys want to talk about or learn more about, just send me an email, and then I'll set up some training on it. I plan on doing some training on some other stuff anyways. So I want to tailor this as much to y'all's needs and what you guys want, rather than just kind of giving you stuff that you don't want or don't understand or don't need in the future. All right, thanks guys.